Here, I'm going to determine whether or not these two matrices are inverses of one another. So first of all, I notice that they're both square matrices and they're both 2 by 2, which means their product matrix is also going to be 2 by 2. So in order to ensure that they are inverses of one another, I'm going to multiply them, and I'm going to see if the product matrix is the identity matrix of the same size, 2 by 2. So let's go ahead and multiply these two together and see what we have. So -3 times -2, we're going to work across the first row and down the first column. That's going to be 6, plus 4.5 times 4 will be 18. Well, at this point, I could go on, and I could go ahead and find the entire product matrix, but right here, 6 plus 18 is 24. So I know that these two matrices are not inverses of one another, because if the product matrix has to be the identity matrix, that means it would have to be 1, 0, 0, 1. But I can see right here it's not going to be. So these two matrices are not going to be inverses of one another. And if I went ahead and worked out the multiplication here, it's going to end up being 24, 0, negative 49.5, and then 2. So yeah, I can see that these two are not the same. So when you're doing this, you can go ahead and multiply everything out if you want to. So I'm not going to take the time to show all the work. But as soon as you come across a term that doesn't fit the identity matrix, you know you don't have to go on, and these two matrices are not inverses of one another.